Now we're going to add and subtract. Remember, when you add and subtract with fractions, you have to have a common denominator. So the same thing is here. We're going to look at our denominators and find our LCD, our lowest common denominator. So just looking at our denominators, we have an x and a y, so that makes it easy. Our LCD is going to be xy. So that is our new common denominator. So I'm going to put xy. Wait, I'm going to write up here. 5 over x plus 4 over y is our problem. I'm going to change this to where I have a denominator of xy. So I am looking between the old denominator and the new denominator. And what is missing is a y. So I would have to multiply that x by y to make it look like this. So that means I have to multiply the numerator by y. So that gives me a new numerator of 5y. Then over on this next fraction, I would have to multiply the y by x to make it look like this. So that means I have to multiply the numerator by x, so that gives me 4x. So now I'm going to add the numerators, which will be 5y plus 4x, and that's over the common denominator of xy. Now, I can't add those two because one's a y term, one's an x term. There's nothing common I could factor out. It's a binomial on top, a monomial on the bottom, so I couldn't factor everything. There's nothing to factor, so there's no common factors to cancel. Because remember, you can't cancel a monomial with a binomial. This is a similar one. 9 over x minus 5 minus 7 over x plus 5. All right, so we want to figure out the LCD. We're looking at the denominators. We have a denominator of x minus 5, and we have a denominator of x plus 5. So those are two different ones, so I have to include both of those in my common denominator. So I'm going to have x minus 5 and x plus 5. That's going to be my new denominator. So if I change the denominator, I have to change the numerator. So looking at this first fraction, I have an x minus 5. To make it look like the new denominator, I would have to multiply it by x plus 5. So that means I need to multiply this 9 by x plus 5. And I just put it on the left side there, that x plus 5, because I didn't have room on the right side. So I'm going to multiply right here, distributive property. 9 times x is 9x, and 9 times 5 is 45, so plus 45. So that's my new numerator. And you want to go ahead and multiply, because if you just bring it down, then you tend to kind of cancel things, and you can't cancel, it goes back to the original problem. So go ahead and multiply that through. So now we look at the next fraction. We have an x plus 5. We want it to look like the new common denominator of x minus 5. So that's what we're having to multiply both the numerator and denominator by. So that will give us, notice I brought down the minus there. 7 times x is 7x, and 7 times negative 5 is negative 35. Now, here is where we have to be very careful. This is a minus, so it's going to change the signs in the numerator to the opposite. So I'm going to rewrite this. My 9x plus 45 is the same. This 7x is going to go to minus 7x, and this negative 35 will go to plus 35. So now that is key right there. If this were a plus, we wouldn't have to change any of the signs. We would just look at the 9x, 7x, add them, 45 minus 35, put them together. But it's a minus, so it changes this 7x right here is going to become a negative 7x. And the negative 35 becomes a positive 35. Now, you don't have to rewrite it like this. I just did so you could see where the numbers come from. You can do it in your head, and that's fine. So now we need to collect like terms up here. Add and subtract the numerator. So 9x minus 7x is 2x. And 45 plus 35 will give us, what, 80? And that is over x minus 5 times x plus 5. Now, if we were to factor out the 2, that's not going to give us a binomial of x plus 5, right? That would just give us x plus 40. So let me show you what happens if you do that. So I combined the 9x minus 7x, that gave me a positive 2x. The 45 plus the 35 gave me plus 80. So I collected like terms. Now, I could factor that numerator. Denominator is already factored. I could factor the numerator by taking out the 2, and that would leave me x plus 40. The only thing I can cancel are binomials, but I don't have a x minus 5 or x plus 5 in the numerator, so there's no need to do that. Either one of these answers would be good, okay? Either one, this one or the other one. Now, there are two methods to simplify this complex fraction. I'm going to show you the easier method when you have more than one term in the complex fraction. I think this is just the easier way. So first, you look at your denominators and you find your LCD. Well, that is c minus 2. That's the only denominators, right? C minus 2. So now I'm going to multiply each term by c minus 2 if it's not a fraction, and c minus 2 over 1 if it is. So this 1 is not a fraction, so I'm going to multiply it by c minus 2. This is a fraction, so I'm going to multiply it by c minus 2 over 1. Because c minus 2 and c minus 2 over 1 are the same thing. This is not a fraction, so c minus 2. This is a fraction, so c minus 2 over 1. So now I'm multiplying. 1 times c minus 2, well, that's just c minus 2. Then right here, c minus 2 cancels, and that's 2 times 1, so that's plus 2. See how the fraction goes away there. Then 1 times c minus 2 is c minus 2. Right here, c minus 2 cancels, so that leaves you negative 2 times 1, so that's a minus 2. Notice how the signs change that last number. So now we want to collect like terms. So we look at this minus 2 and plus 2 go away. So that's just a c. And the bottom, these, bring down the c, minus 2 signs are alike. So you add, take the common sign, so that's a negative 4. So that is our answer, c over c minus 4. And it looks like they want you to put the numerator and then the denominator.